we're going to do a chain rule. I have xy equals cotangent xy, and I want you to find dy dx. I want to find the derivative. Now, this is not a function, right? And we're going to have to do implicit differentiation. All right? We're going to still do it in terms of dy dx. And again, we're going to talk about a shortcut in a day or two. So I look at this problem, and the first thing that's got to jump out at you is that this is a product rule on the left, and it's a trig function that's going to have a chain rule and product rule on the right. All right? And again, you must put in your memory bank some rules. First, you better know what the derivative of cotangent is, right? And you probably haven't memorized that yet. It's cosecant squared x, right on. And we're going to need to know the product rule. And for some reason, I didn't copy that down earlier. We're going to have to remember f prime g plus g prime f. All right? Now, again, I just put those down for reference. I am not going to spend a ton of time today writing this out. We're going to do each as we go. I'm not going to call f and g on x and y. Again, if we practice that, we have to get more quick at it. But those are the two rules we're going to use. I'm going to pull those just down out of the way. I always do the product rule the same way. I look at the first factor, x, and say, hey, let's take the derivative of x with respect to x. Derivative of x is 1 dx times y plus x, because I already did the derivative of that. What's the derivative of y? 1 dy. And I'll put the 1 so we see it today. Equals. All right. And now I have a chain rule. And the big mistake I see on students is you guys want to change the argument. We don't change the argument. So I know that the derivative of cotangent is negative cosecant squared xy. And now I have to do the derivative of the inside. Exactly, and again, it's going to seem awfully familiar to the other side. I got to make this a little smaller so we have some room. It'll be 1 dx times y plus x times 1 dy. Because guys, it's xy again. It's xy again. And now we are done with the calculus, guys. Now it's algebra 2. And this is why I make those jokes. Algebra is what kills us, right? We have to separate the dy dx's, all right? Now we're going to talk about doing y prime direct here next week. But right now we're going to keep this going. So I'm going to put those rules off. And I'm going to distribute and simplify. So I'm going to write y dx plus x dy equals, distribute here. I'm going to get negative y cosecant squared xy dx plus, not plus, when I distribute the negative, it'll be minus x cosecant squared xy dy. All right, I'm going to separate the dy's and the dx's, or I could divide by dx right now, but I'm going to separate today. I'm going to put all the dx's on that side. I'm going to put all the dy's on this side. So I get x dy plus x cosecant squared xy dy equals, I'm going to get negative y dx minus y cosecant squared xy dx. All right? And now I'm going to factor out, and again, this is all algebra time right now. I'm going to factor out the dx and the dy. And I want to get the derivative dy dx, right? We want to use the different, so we're going to divide by dx. And I'm going to cheat today, because that's going to give me dy dx times this factor, which is a sum. So I'm going to divide by that at the same time. I'll do it in blue so it kind of sticks out. And when I do that, guys, I'm now write the derivative. dy dx. I'll call it y prime at the end here. And I want to do one thing. I want to show you, because again, one of the things that I see happen on the AP test is I will agree that the derivative we have calculated is this. So you guys who are taking the AP, I want to be clear that we have, when we get to these answers, we have to be prepared to look for other forms. A lot of times I have noticed on the AP when they have this situation, they would factor out the negative y. Factor out the x. And look what happens, guys. All right? We have a common factor. All right? So, again, if I bring up the whole thing, we can cancel that out. And we can do the chain rule. Now, or the chain rule. I'm sorry, implicit differentiation. It had chain rule and it had a product rule. All right? Everybody, we are going to change this a little bit next week. A lot of times, most instructors just run right to y prime instead of doing the dy dx. And we'll start that next week, because every time we write a differential here, a lot of times we can think to ourselves, I can divide every term by dx. And it's kind of a shortcut. All right? All right. I want to talk about higher orders. We've already lost some time here.